Welcome everybody to Dallas Personal Robotics Group Robot Builders Night Virtual for February 3rd, 2026. Tonight we will do our normal roundtable with our presenters and then open it up to open mic for any questions, try to stump the club, or just things you may have found on the web. So, no housekeeping tonight. We're caught up to date on all of our business, so we'll kick it off right away with Mike and an update on his. Is your mini sumo, Mike?
No, it's my bigger robot that does the 6-can and the other stuff. Yeah, but I might try to do the mini sumo for the quick trip. I think it has the capability to do something in that area. Yeah, doesn't have to be very smart, because the mini sumo is just a single RP 2040 with one state machine. that's enough to do quick trip. Yeah. But the robot I've been working on is the one for 6-can. Oh yeah, let me bring up my README file. Hold on. Hold on, I forgot to bring it up.
Okay, here's my horse.
Holy Marmaduke.
Just visiting.
Okay, so I'll share this little screen. Yeah, so this is the last year's robot. This is my 2025 robot before my modifications, and I've been taking a picture. I need to take a picture because I think I got all the hardware where it's going to be, all the sensors and everything. But you can see here that it has a power module and a motor controller and a sensor module, and the Raspberry Pi is stuck over there. And it has a powered USB hub. So I use the way I connect to my peripherals, like my LiDAR and my camera, which is a open MV camera, and the motor controller is through the through USB cables. You can see that red one there going to the motor controller there. And then this is the bottom, and so this is. We're talking about the servo I was using. So that's a servo. And so basically this arm swings around and puts the can right here. So they both swing and pull the can right into the catch there. I've upgraded the catch to something that'll stabilize the can. That's just not the width of a plywood, because last year I was trying to slide under the robot and was really messing it up. And instead of 2 switches, I just have one in the very front here or back. These are the motors and the wheels, and then my battery and the caster wheel. The battery is a camera battery, so it's 16 volts. And the power module converts that down to 12 volts for the motors, and then 5 volts for the Pi, and 5 volts for everything else. So that's the robot here. So what I've been doing is I've been working on my sensors. I have a laser on here. I put it on the bottom on my new camera because I had to pull the LiDAR way down. Because before last year, I put the LiDAR up high so it wouldn't see the cans, and it would just concentrate on the walls for localization. And I pulled it down so that it can see the cans and the walls, and it works well for localization too, because it can, the ROS2 AMCL can easily just ignore junk and match what it has to do. And so it does most of my sensing. Like before, I had a front time of flight sensor, just a single point one to pull the can in, and now I can do that with my LiDAR. So it gives me a good measurement. Okay, I'm going to do something different here. I'm going to stop sharing. I'm going to, like, here's my robot there, but I'm going to, let me see. I need to share again. Where's my share? The screen's at an angle here. Okay, so this is something that I've, can you see the RViz?
Mm-hmm.
Okay. So this is the robot that you can see over there. And it stopped working. Oh, there it is. Oh, got to work on the camera detection, and this spot right here is the can. Like I put it 1 meter away, and so the LiDAR says it's at 1 meter, and when we see that little cross go up, it means the camera detected it, and I converted it to a map coordinate. For the distance, I'm using the height of the can in the blob detection. Looks like my blob detection needs some more tuning. There it came back. And so I use the height of the can for the distance, and then the field of view, the pixels on the field of view for this direction here. I believe this is X on the map, this direction, and this is Y here. So it's so you can see that it's pretty close to it. I probably have to try to calibrate it a little better. But if I go over here, and so what I did was I got all the sensors, the laser sensor, it's not a sensor. So I got it pointed at the can, and then I gave it some simple drive command, like say, just go at this meters per second for so many seconds, and it would go in a straight line and follow the green laser. So I could put the can there, put the laser in the center of it, and then say, follow the, just go straight without any feedback of any sort. And it eventually, after adjusting the laser, it went straight. I was real happy that all of my wheel software still worked and it drove straight. So that's good. And then I made sure that my LiDAR right here, the can is that little red spot there, and it's pretty much in the center, and it's good. And then my camera is lined up also, so everything is directional properly. Everything's calibrated that way. I'm going to move the can. So if I move the can a little to one side, you can see that the LiDAR moves and the my camera detection moves. And if I move it to a 1/2 meter, where's that? Right here. Okay. And at a 1/2 meter, yeah, you can see that my camera detection is getting closer to the LiDAR. I trust the LiDAR. And then these dots here are my time of flight sensors in the front. And they're seeing the can also. So at this point, all 3 sensors see the can at the same spot. So sort of at this point here, I'd probably switch away from the camera mode and start using these sensors for can detection, because eventually it's going to get too close for the can to detect with the camera. And so if I bring it closer, looks like the camera stopped detecting and it's just fading out here. Okay, so the camera's failing to detect the can because it just got too close. It's just the bottom of it's getting cut off, and it doesn't meet the requirements for a can. It sees a partial can, but you can see here that the LiDAR detects it and has that shape sort of that you see for a can. It's sort of a rounded shape, and so I know where the center is. And then these two dots here basically tell me that those are the sensors that detect the camera from both sides. Oh, so if you see here, can't do it, but so the can's getting closer. But we'll just look at the RViz, and then I've designed the time of flight sensors so that this is a 90-degree sensor and that's a 90-degree sensor. So basically points out like this, and when the can is here, those won't see it. And the idea of that was to use them for obstacle detection as you get close, so it can see around the can when it gets grabbed. So if I push it all the way into the catch, you can see that, of course, the camera doesn't detect it anymore, the blob detection. These don't see it anymore because it's not within their range, field of view. And the LiDAR detection shows that it's in the body of the robot, but there's actually a notch in the robot. So that's my my sensors. Oh, and these things here are the antennas on my my router. So if you can see the, oops.
So after you get the can, what do you use to get to the goal?
My computer decided to screen lock on me. Hold on. Oh, well, I'll use AMCL to know my position on the field, and then I'll just grab the can and go to the goal. Because I'll know where I am and I know where the goal is relative to me.
Mm-hmm.
Okay, because the AMCL will give you the position of the robot relative to the walls.
Yeah,
which is the map. Just basically, I give it a map of the arena, so it knows exactly where it's at.
Okay.
Yeah.
So is it like in the form of X and Y on the course and rotation of the robot platform on that at that point?
Yeah, you know all that from the
Pose, essentially.
From the transforms, ROS2 transforms. It tells you where's the location of the robot, which is in ROS parlance is base link. The base link transform. Where is that? And where is the goal? And so basically, the XY coordinates of your robot, and the XY coordinates of your goal because it's fixed. Mm-hmm. So you just head that direction. And at this point, if there's other cans out here, I can avoid them as obstacles.
Mm-hmm.
And the LiDAR will do it. And I was thinking of using these for if there's like a fallen can or something, so I can see it and avoid it. So the time of flight sensors, these little eyeballs there. Pull it out. Yeah. So you can see that Yeah, so I can see stuff here. These can see obstacles, and the LiDAR can see the obstacles. And the thing is, what I'm going to do is I'm going to take the normal scan, which is everything. And since I know where the can is, and the distance to the can, I know how much of the LiDAR of the scan to remove, and I'll make a new LiDAR scan file that does not have the can information. And so, and I'll use that for AMCL, and I'll use the whole one, or I'll use that for obstacle detection, and use just a regular scan maybe for the AMCL. But the trick is not to avoid the can as an obstacle. And so, so I can modify the laser scan file, or not file, but the topic, and just take out some of the stuff and then send it to the obstacle detection. Maybe call it scan_obstacle or something. But yeah, as a new topic. So that's my plan on that. And so that's sort of my robot. But one of my projects over the last week was to find a way to run RViz on a PC, a Windows PC. And so this RViz is running on my Windows PC, and I found a way to do it. Something called Pixie. And so I'm going to stop sharing. Is there any more questions on this robot, or I can bring it back up? Okay, stop sharing. Then
I have a question. The is all the calculations done on the Raspberry Pi or on your other computer, or? Oh,
Raspberry Pi 4. I'm using a 4. And it gets hot.
Oh, it does. Oh,
yeah. Wow. Doing the calculations and stuff. So it doesn't need any external. It's just all self-contained.
Oh, okay.
And the only thing I use the computer for is development, like writing the code.
Simulation.
And I use VS Code in a remote mode. So here's, so, and also, and I found a way to put, what do I call it? To put RViz on my computer. And I'm using this here. I'm going to, so basically something called Pixie. Have anybody heard of Pixie before as a package management tool?
Nope.
I haven't either, but I was just sort of Googling. It's like, okay, how can I run RViz on a PC? And I put this on it, and it just worked. So basically, like if I bring up the, let me see, let me go back to here.
We're not seeing your screen if you're sharing, Mike.
Oh no, not yet. Okay. So if I bring up the, must be it. Okay, so this is the screen running RViz on the PC. I'm going to stop it. And so basically the command is Pixie run RViz2. Once you've loaded the stuff in and configured it, and then it starts activating it. It's just, building its environment. I'm not sure what that means. I need to learn more about Pixie, how to configure it better or more thoroughly. But it just in the RViz 2, which is good. And I can do ROS command. You can run ROS under it too if you wanted to. And so now my RViz is back up. So that's the so I like that. It's like, hey, I don't have to use my big laptop for Linux, which I had. And so let me try to drop that into the chat. Yeah. So this is the I dropped into chat the link. So I thought that was interesting. I need to learn more about it, but everyone's calling it the newest, latest and greatest package manager. so I was pretty happy that it worked, and now I can run everything off of my Windows PC. And also I use the let's see, let me pull up the.
So is it a package manager for Windows?
And for Linux, yeah.
And Linux as well.
So it can run Linux stuff under Windows, just in the Pixie environment. And you could also use it for your package manager for Linux, but it has so many nice packet managers. Why would you bother? I'm not sure. Yeah. So this is my what do you call it? Oh, visual code, and I have it remotely connected. Can you see the visual code workspace?
Mm-hmm.
Okay, and so you can see that it's connected to this IP here, which is everything, and so I have the environment here. One interesting thing is if I stop the program or the ROS, I can use this serial monitor to debug the quote unquote Arduino serial ports, because everything's connected to the Raspberry Pi over the serial port. So I can say, what would happen if I said start monitoring? Oh, you can do it while it's running. Yeah. So this is like the commands that come from the open CV camera. Oh no, it's not. Okay, there they are. Yes, so it's given me the information from the blob detection. So that's pretty good. I liked it. So you can actually run. You can see what the serial ports are doing remotely. And ideally, you can run, you can program and load and everything Arduino, which instead of Arduino IDE, and you can run, of course, other ways to do it, like Platform IO. But so this is what I can do now is I can just remotely log in. I can use the I can do the version control to the GitHub, and so this is telling that I did some modifications to the parameter YAML file, and I deleted 2 old files. So I just what I did is I copied my robot code from last year and made a new repository. Now I'm sort of cleaning it up, taking the old junk out. So.
Are you running?
All said and done, can you get 6 cans in the goal in less than a minute and a half?
It's ROS. I'm going to try to get it faster than 4 minutes. Yeah, I think last year I could do it in 4 minutes.
Are you running ROS natively on your Pi, or are you running it in a Docker?
Oh, natively. Yeah, natively. I like the path of least resistance. So, I mean, I sort of wish I'm debating whether to change from Humble to Jazzy or something newer. For my outdoor robot, I was using Jazzy, and I'm sure I can load the Ubuntu 2404 on the Raspberry Pi 4, and then update the ROS to Jazzy and do whatever else has to be done. So
Are you
that
running
might be,
full,
huh?
Are you running a full desktop version on the Pi for
No.
Humble?
No, I'm just using this. I'm just doing server. I'm the Ubuntu Servo, so there's no graphical capabilities.
Okay.
On my other robot, I with the Raspberry Pi 5 and a nice SSD, I put the full desktop on. Yeah, and it worked fine on a Pi 5. So, but the Pi 4 is just sort of underpowered, so I figured, just let it run the code. The ROS is pretty demanding, so I figure that's enough. It doesn't have to do graphics. So that was like on my other robot. I would just VNC to my robot and show RViz. That was nice. And now I can just run RViz and Foxglove on my PC. So the two development or two visualization is Foxglove and RViz. RViz is a little bit more compatible with ROS, but Foxglove is pretty good. But Foxglove has a lot more tools to use. So I like it when I get into serious debugging. And
So for Foxglove, do you have to put anything on the Raspberry Pi? Or are you just looking at the ROS messages?
For RViz, there's nothing extra on it. But for Foxglove, you got to put a bridge on there.
Okay.
Yeah. So you just run the bridge on it, and it just bridges. Can't remember the exact name of it, but it's a bridge. I'd have to bring it up and see what it is. So it's just some code that you load onto it and then activate it. So it works really good. But yeah, because the Foxglove you can't just do packets over DDS like you can with RViz. You have to put some bridge layer in there. So that's what I did last week.
Well, thanks for the update, Mike.
Uh-huh.
Next up, we have Mark.
Okay, so I've been playing around with some gearbox designs here recently, and my latest one is playing around with cycloidal drives, which are actually a fairly nice compact gearbox. So I have an example one here, and sorry, it's printed in black because I do all of my prototyping in black PLA. This is the 3D printed gearbox here. So you can see the cycloidal motion slightly there. And if you look on the back side, you can see the 10-to-1 reduction.
Mm-hmm.
If you put any significant power on it, does it bind up or?
What's that? No, it's actually
pretty good. So
fairly smooth.
Yeah.
I've got, I actually use a 3D printed bearing, so similar to this.
Oh, kind of raise it up a
Can't
little.
see it.
Oh, sorry.
There we go.
So it's
So it's
actually
3D printed ball bearing or something, or bushing?
basically it's a 3D printed bearing, except for the bearing balls are airsoft BBs.
Oh, okay.
Good.
So if you look carefully at the bottom of the drive here, you can see the blue airsoft BBs that are there in the that are forming the bearing.
Mm.
And then basically the way you put it together is You line up those two slots, and then you can basically push the balls into the race.
They don't
And it
fall
actually
out.
makes a nice secure
Hmm.
bearing.
They don't fall out, huh?
What's that?
They don't
No.
fall out.
Not if you size it right.
Oh,
I guess they click in.
The idea is to size that hole so that they have to actually be forced in.
yeah.
And then as the bearing seats, as you get all the balls in, it basically ends up sealing that hole.
Mhm. That's great. Good design. Yeah. Did you design it
No.
yourself or use someone else's design?
I used a tool to design the basics of the cycloidal. So here's the output bearing here,
Mm-hmm.
and then the actual cycloidal here.
Huh.
So you can basically, so I have the cycloidal is on the bearing, and then that side's on the bearing, and I'm just using the pins for the pins don't have bearings currently. So if I put this together backwards, I can probably better show the motion of the cycloidal.
Did you ever hear of harmonic gears?
Yep.
Yeah. You ever try to make one of those?
That's a 3D printed flex spline for
Oh.
harmonic drive,
Oh.
but I haven't finished that one yet.
Hmm.
But I've been playing around with some different materials for that one.
So you have a particular robotic project, or are you just doing it for fun, for learning?
A little bit of both.
Okay.
I have some stuff for work that will use it. So
Cool.
yeah,
I think either one can be pretty expensive if you have to buy them, right?
Yeah, they're pretty pricey if you want to buy them, but they're actually in Fusion 360. If you get the add-on for it, they're actually pretty easy to make. So let me see if I can share my screen here. So this is a design in Fusion 360 for that cycloidal. So I can hide the handle and the cover. We can actually go ahead and bring it up piece by piece. So the input shaft basically has basically is the offset hole, and you can add in the disc. And basically you can see the bearing race that's in there for the bearing. I hide the disc again. So you can see it's basically just cut into the side there. It's a little bit more prominent on the output shaft. So the output is basically tied into the housing. And then with the cycloidal on top. And this actually uses, it's created with a tool. It's by this designer. And so it lets you basically enter in all of the parameters for the cycloidal. And then when you generate it, this is what it actually generates. So it generates the disk and the output. It gives you a simple disk for the offset for the offset shaft, but doesn't do the shaft. But then from there, you can basically build it up into however you want to hook it up.
Did these designs come from like oil pumps? Because it looks like it'd be a pretty good oil pump or a fluid
that?
pump.
I don't know what the Cycloidal drive was initially designed for.
Mm,
I know it's used a lot in like the robot dogs and stuff like that because it's easily back drivable, and it gives you can get a lot of reduction in a fairly small size.
hmm
So this one is a 10-to-1, and then one of the disadvantages of them is that if you run a single disc, because of the fact it's going offset from the main axis, you can get a lot of vibration at them at speed. And so usually you run a double disc to basically balance out that vibration. And that one is the one that I'm working on doing a double disc version. But I haven't completed it quite yet.
Are the two discs offset by 180 degrees?
Yeah, the two discs are offset by 180 degrees. So if I hide the discs, you can see how the shaft, that's
Yeah.
the shaft that drives them. So it's 100, basically the two offsets are 180 degrees out of phase.
What material are you printing these out of?
I've just printed them in PLA so far.
Yeah. Well, I guess probably the disadvantage of the harmonic is that you're actually flexing or stretching, like with a wave generator, that disc that you showed earlier, that has to be deformed for it to work. Whereas this doesn't. So
Yeah.
yeah.
And the harmonic normally isn't back drivable very well either.
Oh no. Yeah.
So it's so that's one of the big advantages as the Cycloidal is that it's back drivable, even when you're running it at a higher gear reduction.
Cool.
But they're fun things to play with. Are there any questions or anything?
So you're going to print it with tougher filament, carbon fiber or something like that?
I'll probably do ABS or an ASA for my use case. But actually, PLA actually works well, especially with these airsoft bearings. As long as you don't put it outside in the sun anyway.
Don't leave it in your car.
But with modern PLAs, even for these bearings don't generate very much heat at all, even when you run them at fairly high speed. So the only thing that I would need to do on the stop sharing here. The only thing I would really need to do on this one to make it a little bit more robust is to add a bearing into the covers so that where the shaft is rotating would have a bearing, and then it would hold up just fine, even under fairly severe loads.
How many trial and errors did it take to get the bearings to fit right?
On this,
Yeah. Or,
this was
yeah.
a one print and done. But
But-
that's because I have a lot of experience doing it.
Oh, okay. Okay. Okay.
Although the bearings are fairly simple to design. If you're interested, I can kind of show you a simple design for one.
Yeah, because I know you said it has to be precise so it clicks in. So that's like, oh crap, a little too big, oh, too small, just right.
Usually most modern printers these days, their tolerances are pretty good. So I generally use a tolerance of on diameters of between 0.15 millimeters and 0.2 millimeters. And by using those tolerances, they work almost all straight out of the box. If you've got an older printer, you might need to put a little bit more.
Yeah, my 15-year-old printer takes a few times.
Well, thanks, Mike.
So that's what I have. Just something simple.
That was it for our list of presenters. So open it up to the floor for questions, comments.
I could do something, I think. Kind of get your feedback as to whether I'm caveman using bear skins and bone knives or not, but I probably am. So anyway, okay, let me see if I can do this. Oops. Got to get that out of the way first. Share. Okay, I'm going to do a window. And because there's all right. Do. And share. Okay, here's okay. Not doing something right here. What is it? Okay, let me see if I can find this. Can you see my screen? No, you cannot. So totally unprepared here. Recent.
Yeah, you're sharing a R on a brown background.
Yep, I see that. Okay. What am I doing wrong here? Okay, there we go. Can I share that? Can you see that? Aha.
Yay!
Okay. Okay. Yeah. Okay, so this is, let's see, do you see the, let's see if I can blow that up. You're not seeing that. Darn.
All we're seeing is your file explorer, right?
Yeah. I opened up another window, but
I think you're
Okay.
sharing an app and not a window.
yeah. Let me go back to this screen. A window. There it is. Anyway, so basically it's like a requirements document for Copilot. So just a bunch of text. I wanted to, well, I'd asked Copilot what I needed to get robot pose and what's the minimum number of beacons, and it said 3, and that gives me X and Y coordinates on the course and the angle or theta that the robot is sitting reference to, some point on the course, usually like the 0, coordinate or something, which way it's facing. So, and you can also go at it with 4 beacons, and because you may not, one of the beacons may not work so well. So you can still use 3 out of the 4 that do work. So basically described, here what the course was, what the coordinates of the beacons were, with respect to the course, gave it information on how many sensors, which angles they pointed at, so it could figure out, like it saying here, IR sensor 1 is at 10 degrees, 2 is at 30, 3 is at 50, and so on, all the way around the that black 3D printed form that actually holds all the sensors. Gave it some information about timing, because the robot uses basically a radio setup, and it can actually transmit whatever pulse width you want to send up, well, within reason, somewhere below a millisecond is good or works well. And then kind of the idea was that the robot would send out different pulse widths, and all beacons would receive it, and they would try to measure what that pulse width is, and then each beacon would would only respond to a certain pulse width. So it, as far as the timing, it's in 10 millisecond blocks for each beacon. The robot would send out, like, say, for the first one, I think it's 400 microseconds or 0.4 milliseconds for high pulse, and the second one gets 600 microseconds. So it actually measures that pulse width and only responds when it sees it. So then each beacon would turn on the 38 kilohertz infrared, and the IR receivers on the robot would pick that up, and so it could determine what angle the light from the infrared sensors is hitting the robot, independent of how the robot is orientated, because it's just a circle of sensors, and where it hits depends on how it's orientated and the course at any given time. Anyway, so I gave it some pin information, which ones were connected to which pins on this is an Arduino Nano. And apparently some of the clones, A6 and A7, you can actually do a digital read with, but on a real one or a direct copy, apparently A6 and A7 are analog inputs only. There's, you can't use a digital read on it. So with all that, it generated that down. And I gotta squeeze that down. And get rid of that.
Yeah. So Ray doesn't do vibe coding. He creates a whole description, and then he iterates by redoing the description and recreating the entire code from scratch.
Yeah. So let's see. This one is not the one. There's another one. Open recent. Oop, where'd it go? Oh, beacon 4. There it is. And I can get rid of that one. Okay. So I can stop sharing, go back to the call, and open another window. Oop. Two screen, window, this one. Share. Can you see that?
Mm-hmm.
Oops, I just hit it on myself. Okay. So I'll try to bring it up. Bring it down. So this is the code that it gave me. And it uses okay, very top. So basically use the sensor pins that I told it to, including it. There's a pin 12 was the transmit pin on the robot, because this is the robot side, not the beacon side. Basically, it accepted the right coordinates for where the beacons are, beacon 0 through 3, which is good. Hit count is for when each of the beacons turns on their infrared transmitter, it's going to hit certain infrared receivers on the robot, and you can't leave that infrared transmitter on for very long. If you do like 1 millisecond burst and in 5 milliseconds, it tends to saturate the receivers. So I actually had to do like under a millisecond burst. So that's the 400, 600, 800, and 1 millisecond for the last one in 10 milliseconds. So each beacon, or for each beacon, it takes 10 milliseconds. So total is 40 plus a little bit of processing, but that's okay. My robot refresh rate is every 50 milliseconds, so there's enough time to do it all. Anyway, one of the things that it used, I remember taking these course, I don't know what it was called, maybe computational methods or something. Anyway, this used one that I thought I had used before, or found out about in this course, called the Gauss-Newton approximation technique. So that's what's used. Anybody that ring any bells for anybody, or use it for nonlinear equations? And basically it's like you put in a seed, and it it tries to minimize, you specify what the error is. The error can be pretty small. Like, I don't know, 1 times 10 to the minus 6 is, as far as an amount of error for for X and Y, it's pretty small. And it iterates each time and tries to minimize that error. And so it was kind of neat to see that again. It's like, yeah, I think I remember that. Anyway, so I asked it to take the mean of the like the number of hits each sensor got. So it's like, maybe sensors 2 and 3 got hit 6 or 7 times. Maybe the ones on either side of that got, also received it, but less, so that basically I wanted to get a mean angle out of it for each beacon. So does that, and there's the Gauss-Newton using, well, this was 3 beacons, but that's all you need for the 3 variables X, Y, and theta. So the 4th is there in case, maybe it got weak reception on a beacon, or no reception or something. It can still work. Anyway, so after all of that, it does come out with basically the estimation for X, Y, and theta. So I haven't tried it yet. I got, 2 other beacons. That's kind of what's in this tray here. So that's kind of what a beacon looks like. It just has, that's a nano. That's the infrared transmitter, and this is the 433 megahertz. I think these are amplitude shift keying. I'm not certain. There's not a lot of documentation on it. But those work pretty good. These actually work better than the older style. If one was super heterodyne, and the other one is something different. I forgot what it's called. But one of them, if you don't provide kind of like keep alive pulses, it'll increase its, the AGC will start to increase, and it's like static on a radio. You'll just get random outputs, and these don't do that, which is kind of nice. And they're supposed to be more stable because they're crystal based, not inductor and capacitor based. So anyway, so the only thing that changes for the 2 additional beacons is which number it is, because that tells it which pulse width to look for on the radio receiver. So, but anyway, so I thought it was kind of neat. It seemed to do pretty good. It worked well, with 2 beacons, but with 2 beacons, I can just find the center of between where the 2 beacons is. So, and the other thing that I tried is, I hadn't tried it yet, but I said, okay, I have another scenario. I've got an OpenMV H7 and a laser with a line lens on it. Can I get pose from that? And it asked me a bunch more questions, and I responded back to it. And it actually generated Python code to work with, basically I could load it into the OpenMV IDE, and I haven't loaded that on yet, but I'm kind of curious to see what it does and how well that works. But it was kind of neat to see it. It can do things much, much faster than I ever could. And it's kind of neat to be able to say, okay, this is the scenario. I have these sensors, and I use this IDE, and I want this written in Python, not C or C++. And I even asked it if it knew about the OpenMV IDE, and it said it was, it knew about it. It was familiar with it. So that's like, okay, that's good. So, I'll have to try it. It's like I said, it's a whole lot faster than sitting there doing research and writing out each individual line of code. So, but as far as, is that similar to what you guys do? I'm guessing you use like, GitHub for like revision control, and do you even use scripts like that, or is that back in the Stone Age for you? Chris?
I've done similar using Claude AI, but not into the detail that you went with your prompt.
Oh, really?
Yeah.
So did you check it out? Did you load the code and see if it did what you wanted it to, or?
I tested some of it, yes.
Yeah.
And I'm currently working on it. I'm using it actively in my 6-cam robot.
Oh, okay.
So I'm keep testing it, and I got to tune it. It was part of a motor driver, so.
All right. Okay.
Just having
So
it
are
go.
you doing it to like for a PID loop, or?
Yep, PID loop, encoders, the whole work. So I gave it the prompts, told it to pin, and what I was looking, and told it to spit out a big, huge program. And I said, well, yeah, that's really nice, but split it up into manageable chunks so it's easier to edit.
Yeah.
And it split it all up, broke it up into individual programs, and it did a good, decent job. I haven't seen too much really that I thought was wrong with it so far. I was able to spin some wheels with it, but I haven't done any tuning to get it to move around.
Yeah.
So that's the next portion. So just playing around still. So trying to get everything up and running and rolling and going, but I'm not there yet.
Okay.
So,
Ray,
yeah. So Ray, I was kind of listening only with one ear, so I might have missed that part. But are you using Copilot, some sort of web interface that chat, or built into Visual Studio Code?
Just using Copilot, just loading a text file in, saying here's all the requirements that I have. And
No, I think we've had this conversation before a couple of weeks ago, and I know Karim had some very helpful comments. I mean, he's probably a power user beyond, but I have been using this stuff a lot, even at work. But the one thing you really want to do is you want to use the Copilot extension in Visual Studio Code.
Okay.
So that when you prompt it and you say, okay, this and that, right? So that you have multiple files sometimes, right? And so that it has access to the files. And so you can, when it makes edits, right, you can see the diff immediately, and you can try it and then follow up with a prompt, or you can, if it's going off on a tangent, down the completely wrong path, there's a button you can click. Nope. Undo. and it's like a whole level. I mean, usually you have Git, you still need Git to be able to do another level of undo, but even that Copilot built into Visual Studio gives you kind of an undo. It lets you say, okay, yeah, keep those changes, they're good. No, just undo the whole thing.
Hit the flush lever.
Working out, right? But you still get, because occasionally it decides to make changes that just where the undo doesn't work. But the bottom line is you gotta get that extension. So you obviously have a GitHub account, right? You get certain amount of functionality for free with just a regular GitHub account. I just don't know how much it is, because I have the paid versions for everything. But
yeah,
honestly, I mean, given all these subscriptions we have these days, if you were to pay one of these companies $20 a month, I would say it's money well spent, since you're kind of spending time. I mean, it's you can upgrade your GitHub account basically to something that has more higher usage limits and access to the better models. Again, I don't know what you get for free. Sometimes the free stuff just is not worth even playing with. You gotta have access to the latest. You're really not doing yourself a service if you sort of stuck with just the free stuff. It just does not work as well.
Yeah.
But so either you pay GitHub some money, or you pay OpenAI some money, right? If for a long time it wasn't possible, so I've had an OpenAI account for a long time, and it wasn't possible to tap into that. But they have their own extension, for example, right? So you install that extension. So now it's similar to Copilot, really the same thing, except now you're paying for OpenAI. Well, now you're tapping into that, right? So you don't have to pay GitHub extra money. You're already paying OpenAI. Or if you have a Google Gemini account, the $20 a month one, they have an extension. Okay, so you just tap into that. So Copilot is not the only way to go. There is all the major players have their own extension, but the key is to have that inside your IDE for the best possible experience. Just the workflow, and just so you see what edits it's making, just so you're not copying, pasting files around. It's just not productive.
Hey, Chris, would we be able to talk you into a presentation on working with VS Code and Copilot or Gemini or?
No, you might be able to do that, because although I have not been applying it to robotics per se, not really had much time there, but I've been applying it in other ways, and so yes, I can. I know Kareem has a certain workflow. I know he's doing more sort of the terminal route. That's getting lately a lot of attention. There's certain, the Claude code, right, is in the news and all, right? So where you literally live more on the command line. I like the workflow in the IDE in Visual Studio Code. And so, yes, short answer is yes. I think I might be able to do a solid size sort of walkthrough of how that works. And there are certain things you want to have in place, certain setup, and honestly, there's still challenges. The hard part is still on the front of how do you get the Copilot to automatically sort of test the code that it just created or modified. That's not straightforward, because in other sort of areas, right, if someone's working on a web app, let's say, right, and all the examples you see out there in YouTube videos, right, 99% of the time, someone is working on some sort of web app, right, that some fancy, browser-based application, and it sets up all the back end and the front end, and all kinds of stuff going on, and then these tools do that really well. But the point is, that sort of thing, because it all lives on your PC, right, is inherently easier to test. Or if you're doing Python, right, there are times where I do a lot of Python work, and whether it's just the random utility of some sort. Again, it's inherently easier for Copilot to test what it just did, right? It sometimes you have to prompt it, sometimes it just does it automatically, but it literally will write a test and then make sure the main artifact that it produced per your prompt actually doesn't crash. It actually seems to be producing the expected output. But again, it's easy to do for these tools because it all just happens on the PC, right? You're talking to some Arduino-like device. Now it gets more complicated, right? Now, how do you know, at the minimum, you want to teach it how to compile the code, right? Otherwise, it's just like the code doesn't even compile, and then it just wasted your time, right?
Mhm.
Because it will make silly mistakes, right? So, but the point is to really get the most out of it, you know, and where all the hype is, right? To really get as much out of it as everyone is hyping about. You got to do some setup, and for the kinds of things we are doing, that setup isn't always straightforward, right? Because it ideally it would know not just how to compile the code, how to download it, how to run it, how to look for, does it do what it's supposed to do? Oh no, it's not. Oh, let me fix that for you, right? So ideally, you have kind of an end-to-end setup in place where it can do all that. And that's, like I said, it's hard to get there. I haven't gotten there. But even without trying to sort of check all those boxes on setup and making it, getting it to a point where you can test your code, I can sort of do a demo of sorts or a little bit of walkthrough of what a sort of a setup would look like. Yes.
Okay. Yeah, that sounds good.
Okay, I'll let you think about it, and I'm not going to try to hold you to any sort of date, but if you feel you're confident,
I will think about it. Let me think
reach
about
out
what
to anybody in the group and let us know. We'll schedule a date if we can.
Yeah, my testing is download it to the processor and see what happens.
Yeah.
Yeah,
So Ray, do you like if you create the code and look at it and it says, "Oh, I forgot something," do you go to Copilot and just type in the correction, or do you type it into the main description and recompile it all from scratch?
Initially, I would just, if it wouldn't compile, I could say, well, something's not right here. And, if I knew what it was, I would point it out, like, or if it would compile, but it wouldn't give the correct results. Like one of the things it was doing, like for a weighted average, it would actually take the index of the sensor, whatever was assigned to it. It would start with 0. You multiply 0 by anything, you get 0. So it would wipe out what that one sensor, the 0 sensor was always doing. And it's kind of like, I said, okay, don't use index 0, add another space in the array, and use 1 through 18, not 0 through 17. And so I found that it seems like I don't know if I'm specifying it well enough, but it doesn't seem to come up with, errors lately. But initially, yeah, there were quite a few errors. So either things wouldn't compile, or once you got it to compile, it just wasn't, giving you the right results. So
yeah, and part of the trick is, again, you'll probably have heard that buzzword, right? Context engineering. It's no longer prompt engineering, although your prompt matters too. But there's context engineering. Yeah, you gotta really think about what context you give it in addition to the prompt. And by context here, I mean documents, or even just simple document, overview document that kind of captures, here's what I'm trying to do, right? Certain facts that don't change, right? Because keep in mind, these things don't remember, they don't learn. You turn your computer off and back on. It has, or even from session to session, while you're in one session with Copilot, whether it's the chat interface or in Visual Studio Code, while you're in there, it remembers everything from start to finish, and you've been prompting it, and it remembers what it's been outputting.
Yeah.
At some point, it starts forgetting because that session becomes too long. That's another problem. But then you start a new session, it's like it's complete memory loss, right? It doesn't have a clue of what you told it 5 minutes ago. It's simply about all the things you just explained. And so that's why you need to come up with a system, and it can be simple to sort of tell it sort of basic facts about your code base, about what you're trying to do, what is this all about, things to do, not to do, and again, depending on what tool you end up using, and I can see someone's doing Copilot.
that's
Exactly.
Mike
This is
Williamson.
exactly. Yeah,
Yeah.
so this is exactly what you want to be using, exactly that. And then there are things in Copilot that where you give it this context, and I don't know if Mike, you have it. I don't see a .github folder, for example, which there's certain conventions that exist by which you can give it certain markdown files that always get sucked in. So if there's certain facts or certain, like, do this, always do this, never do that, you capture that in a certain document with a certain name in a certain place, and without you doing anything, those instructions always get sucked in, right? So that it doesn't forget, because you explaining it in that file. Never do this, never do that, right? So those are the sorts of things that are part of setup, right? As part of the context engineering. They just make sure you get the most out of it.
Yes. So on my
So
screen,
Mike, do you have the free account or do you have a paid account?
I'm not paying. Yeah, I don't use it much.
Okay. So do me a favor, click on the GPT 4.1. I just want to see what you get with the free account. Let's see. Okay. All right. So you get 4.1, you get 4, you get, yeah. Oh, you get Haiku 4.5. Okay, that one's not bad. So don't,
if I click on that, sometimes it asks me for a paid, but yeah.
oh. Yeah, so the free ones, the 4.1, 4.0, forget those.
Yeah.
It's just you're like living 2 years in the past almost. I mean, not quite. I'm exaggerating. Okay. And you have to realize the rate at which these things are improving. 1 year is like you're using a microprocessor from 15 years ago. It's just it's just it'll work. I'm not saying these ones don't work. I'm just saying if you're gonna spend time trying to figure out how to take advantage of it, don't, you wanna use at least Haiku 4.5 if you have access to it. But there is such a huge difference that the bigger models, they make just so much less mistakes. It's just night and day. Now, if your problem is simple, right, and if you're giving a trivial task,
Right.
obviously it's not going to make a difference. It just doesn't.
Yeah.
But once the task is big enough so that it's actually helping you save time by giving it to the Copilot, right?
Yeah.
Then the big work much better. Now, Haiku 4.5, I will say, is not bad. I have been using that a lot, maybe because it's super fast. So it's not super smart, but it's super fast. And for smaller tasks, I find it good enough.
Yeah.
And it's modern, right? It's not as old as like GPT 4.1. So GPT 4.1 is like 3 generations old. It's also very fast. It's also still relatively good in some ways, because it was good for coding. But Haiku 4.5, one of the reasons it's much better is because one of the things that these things can do, because they live in the IDE, they can work with tools. Right? That's when you're in this agentic mode, the model through Copilot as a host can use tools, and that's multiplies the power. It can, even when your code base has many files, it can search for things. It can use grep and other tools to search for stuff, right? So that it can compile, if you have taught it how to do that. It can run commands in the terminal. And so models like Haiku, which are relatively new, they've been much better trained on how to take advantage of tools. compared to, let's say, GPT 4.1. It's much older. Yes, it can use tools, but it's not as clever in its figuring out, oh, in my environment, there is a tool available that I can use for this. Let me go use that tool. It just doesn't get it as much as Haiku 4.5.
Mm. Yeah, it looks like Copilot, or at least the one what I have access to, is using 5.1 in smart mode.
Yeah, so that's pretty good. So that's in the but that's in your chat interface, right, in the browser.
Yep.
Yeah, so it's a smart model, except you want that in your Visual Studio Code.
Mm-hmm.
Okay, that's what you want.
Mm. Yeah, I always tend to like most of the things kind of contain the code like this. All I really want out of it is the X, Y, and theta, and that's going to come out of a serial port, and either it does it or it doesn't. So so that's kind of nice. It's kind of like the cameras. All I need is an X coordinate where the center of the can is. So to be able to find a can. So, but yeah, it's kind of neat. Anyway, so yeah, and then just to see what it could do with the OpenMV IDE, it looks like it should work as far as it's saying kind of what it's doing in each few statements or groups of statements, and giving you the actual code for it. So that'll be kind of curious to see what it does there. But anyhow, that's all I have.
Well, thanks for the update, Ray. It was good, and thanks for the description of using Copilot or Claude AI or other AIs to help us make code. Look forward, if you can manage to get some time and put together a presentation for us, it would be great. Anyone have anything else for open mic discussions?
Well, in the context of what we've talked about, I don't know how interesting it is, but I did take my first cut at using AI coding tools yesterday. I tried 2 different ones. I'm not pleased with them, but that may be a lot more due to my inexperience than anything else. I can show you what I learned, what little bit I learned, if you like. I'm going to share a couple of things.
Yes, but also don't expect it to magically solve all your problems, right?
Oh, no, but that was the whole point. It's magic, isn't it? First of all, I should show you the context of what I'm working on. Let me plug this thing in. I had mentioned a few weeks back, I had started to play around with April tags, and my April tag implementation, see if this will show up, will make use of my simple ESP32 cam. The code runs on it. I've had it running. It works well. I have not calibrated the camera well enough, but it's looking good. This is simple ESP32 cam stuff. Now, what's interesting about this particular apparatus, this is from the work I did on AI-trained tone recognition from more than a year ago, is that I added a little color display to the camera, which worked very, very well. I don't know how well you can see that. Right now it just shows a blue background. It's got some text and lines on it. Just proves the thing works. I spent a lot of time learning how to program this stuff and use it more than a year ago. So I have a number of test programs that and working programs that work well, but I need to modify this a fair bit in order to allow me to see the April tag image in real time, which the camera is seeing for purposes of working with this April tag application. So I thought I'd do the same thing, show the picture of the April tag, overlay it with the computed results from the April tag processing. I started to look at the code I had and said, here's 400 or 500 or 600 lines of convoluted code mixed up with a bunch of other crap. I want the TFT stuff, the display stuff. I want to drag it out, put it into the code that's running the April tag stuff. And I tinkered away with it for an afternoon and I said, wait a minute, why don't I just ask the AI system to do this for me, right? It's got to be easy. Everybody says it's the way to go. So that's the context. So let me show you my first attempt. Let's find the window. And the window.
So what were you trying to display on the display? Was it just which April tag it was, or?
For purposes of this test build, all I wanted to do was show the camera image on the TFT display.
Oh, okay.
The cameras, what's this say? You are presenting. There.
It's like a notepad file.
Yeah, just all I wanted to do for the first test was to show the camera image in real time and point the camera at the April tags. You've seen the April tags before, I assume. Things like that, right? And I should just be able to see whatever the camera is seeing displayed in real time. Now, the problem is the April tag implementation runs the camera in SVGA mode, so 800 by 600 pixels. My previous applications from a year ago were running the camera in 96 by 96 pixels. I'm continuing to try to run the cameras in JPEG mode. The TFT displays don't run in JPEG mode. They run in RGB mode. So there's a conversion required from 800 by 600 down to the display resolution and from JPEG down to RGB. I have to combine all that stuff together, make it work right, make the picture appear properly. So there's a little bit of finagling going on. So what I did was, and I'll show you this thing. What I did was I took the web page from yesterday and I simply captured the entire web page and stuck it into this text editor. So up at the top, you can see I'm running, this is Claude Opus 4.1. Not knowing how complicated I had to make my question, I simply wrote provide code to display ESP32 cam camera image on ST7735S display. Very naive. But it ought to know what an ESP32 cam is. And I've been fairly specific about the TFT display. Not completely specific because a year ago when I first started to work with these displays, I realized that despite the fact that you have a name, there are at least a half a dozen hardware variations on that particular chip. And the Claude solution provided me with code. In fact, it provided me with 2 text samples of code. Let me roll this for you. Here's one. And then it said, and if you want to try it a different way, there's another one. And then it gave a few suggestions at the bottom saying, here's why this is good. Here's what you should check. Kind of cool stuff. And I skimmed through the code, having spent a day or two looking at my code that I know works, and said, well, it seems to have all the right bits and pieces in it. So I grabbed the first program, dropped it into the Arduino IDE, and of course it will not compile. And it didn't compile for a bunch of fairly obvious reasons, which were easy to fix. Once I had it compiled, I downloaded it. It will not execute. It fails the test that Ray is very familiar with. Drop it into the machine and see if it works. So it doesn't work. Nothing happens. Now I have to work hard. The obvious changes are the AI tool used different pinouts for the display and for the camera than were on my device. So that's easy to fix. It also likes the Adafruit libraries for the TFT display. And that's all very fine, but I learned a year ago the Adafruit libraries do not support the variant of the display that I've got, which means now I'm going to have to tell it which libraries to use. So I can do that. And I'm going to have to tell it the correct pinouts. And I can do that. So then I proceeded to write a second request to Claude. This is all in the course of the same hour or two. I attempted to make the question quite a bit more complex. And I asked Claude to solve it again. And Claude immediately came back and said, I'll be happy to solve this. Pay me some money. And I thought, really? I've only asked one question. And it was a simple one. So that was the end of my Claude experiment for that day. Because I'm not paying it money.
So this was on a free Anthropic account or something?
Free web browser account, yeah. So where did it come from? I don't know. I just said, let's try Claude. Typed Claude, it went to Claude. And I assume it was the right place. I don't know. In fact, I can tell you it's the other thing that happens is once you get to the point where it starts asking you for money and you walk away, you begin to get inundated with emails saying, your application is waiting for you. Just click this button and pay money.
Yep.
Yeah. No, like I said, it's again, the free stuff is nice to just get a glimpse of what's possible, but it's just night and day. I mean, with the free stuff, sometimes you get access to the good models, but then you get like, you get to make one request or maybe 5 requests, and then you're out of, your quota is so small that it's of no use. And sometimes you just don't even get access to the higher end models. So you gotta bite the bullet, pay the $20 a month, and
yeah, and they're looking for $65 Canadian every 3 months. They stopped asking me for the 1 month rate. So here's another, if I can share this, if it will. Not sure what it's looking at. That doesn't look right. Let's try that again.
it shows them Arduino AI assistant.
Yeah, you may be seeing a different thing than me. Let's see what happens here. Try it again. This is just supposed to be a window because I moved this into a window. Okay, I guess that's close enough. So this is the Arduino IDE cloud version because that has their AI assistant. So I took the exact same question and I dropped it into this particular AI assistant tool. I'm not sure what Arduino is using. You guys may recognize it, whether it's Copilot or Claude or something else. It came up with an answer, a single answer, and the answer was similar but not identical to the answers I got from Claude. The solutions still like to use the Adafruit libraries, which is okay, I can fix that. But what I thought was really interesting, can you see this area that I've outlined in yellow?
Yep.
Okay. And can you see the min statements here, the 2 min statements?
Oh,
Right.
that won't work.
You were quick. It took me a little longer to find out why it wouldn't compile.
You pointed it out, so.
Yeah. Now, why the heck did the Arduino AI assistant give me code that won't compile? I didn't write this, it wrote it. I was not impressed. Anyway, there are several other things wrong with this. I finally gave up after several hours, and I have been gone back to taking the examples from a year ago and getting to the point where I can get them to build. I'm now at the point where everything is running. You saw the display running. I'm getting frame buffer overflow errors, and I'm not sure why yet, but I'm sure that that problem is solvable once I understand what happened. I've made a bunch of changes to the pixel resolution and to the JPEG conversion routines, and I've obviously messed something up. So that's been my 2 experiences so far. I assume that the Arduino AI assistant would very quickly start to ask me for money as well, since I doubt.
So why does this not compile? Help me out, guys. I mean, I'm already suffering from brain rot.
Sorry. Yeah.
AI tool so much. So
the min function requires that the data type of the 2 elements inside of it be identical. These 2 data types are not identical, and the min function will not do an implicit conversion of data type. I solved it by doing an explicit conversion of data type, and that makes it compile fine. But why should I have had to do that? When I looked this up to find out why it wouldn't work, the information I got was very, very clear. This will not do an implicit conversion. They have to be the same.
So you said the code doesn't compile, right?
That's right.
So remember how I said earlier,
Yep.
What you want to have a setup where the tool, before it finishes, before it says I'm done, does a compile of the code, looks at the warnings and the errors, and says, "Oops, looks like I made a silly mistake. Let me go fix it." Right? I mean, it will make silly mistakes. The tools, just like humans, will make silly mistakes, but you want to set it up so it can catch at least its own silly mistakes
Yeah.
that can be caught by just compiling the code.
Building a more complex question and stating things like, here are the pin assignments and here's the library I want you to use. Those things don't bother me. But I was really surprised when it came up with a coding error, an error, something an error in the compiler. That really surprised me. And this is the tool that's within the Arduino development environment. So I don't understand why it would fail.
Yeah, well, and so here's the thing. Behind the scenes, they're going to use an AI that costs them nothing. And you get what you pay for.
Yeah, and as I said, I do not know which AI tool they're using in here.
Yeah.
I haven't explored it.
Unless you're paying for that Arduino Cloud account, it can't be something that's...
I may go back and try this
again.
I may go back and try this again with a simpler example, because I really was impressed by the fact that it goes like hell with really simple instructions and gave me something that looked really close.
Yeah.
It was a simpler problem. It might have worked better. And then
Yeah, I think one of the things.
And drop it into another AI and see, hey, troubleshoot this for me. Why won't this work?
Oh, I have done that. I have done that. I mean, I've done that to sort of check, kind of find out which one's better. Like in Copilot, because you can select so many different ones. I've had one of the Claude ones, Sonnet 4.5, do something for me, and then I had. Usually, I'm using Codex from OpenAI, and then I had Codex check it. Hey, is this, because I gave it was something more complicated. It was written in a document, not just a short prompt. I told it, go check that spec that I gave against the implementation. Are there any gaps? And sure enough, the smarter AI found
I admit I'm finding that I can solve a lot of interesting problems. For example, the compiler failure problems. It's becoming really easy to simply drop that question as to what this error is caused by into my Google browser, and the Google AI assistant will come up with really good answers. And I find I'm doing that a lot more in the Google browser. Maybe it'll write the code. I never thought to try that.
Can you add a line to your instructions to say only create code that compiles?
They'd probably charge me money for that.
Oh,
little hand would come out. Amen.
Pat, you used Claude. How much could you ask it to do before it wanted money?
Claude Sonnet 4.5 has never asked me for money.
Really?
But it has stopped execution and told me that I have to wait 2 hours. And so I wait the 2 hours, and then I hit the continue button, and off it goes.
Now,
and so which provider is that? Directly Anthropic or through some other sort of provider?
That was through Claude AI, I thought.
Yeah, so that's Anthropic, the maker.
That's Anthropic, yeah.
Tom, it sounds like you had something from some other website.
I'm just looking at their NAG email, and I think it's from something called use.ai. Does that ring any bells?
Yeah, so because there are providers that basically are a middleman. They give you access to all the models, like from everyone, right? And you pay them a monthly or quarterly fee, and now then you have access to not just Claude, but like I said, everything. But if you have an account with Anthropic, right? Well, with that you get access only to the Claude models.
So Pat, maybe you can send me the link to the actual server you're using, and then I'll switch to that and see what happens. Because I was using 4.1 and you mentioned 4.5 for free.
I'm using Sonnet for Claude Sonnet 4.5.
Okay.
For free?
For free. I'm not paying anything for it.
Yeah, send me the link.
That's not bad. That's not bad. If you get Sonnet 4.5 for free, that's not bad, because Sonnet 4.5 pretty decent.
I'm just going to go verify here, and I haven't
Yeah,
been in it in a
You know
while.
what it is. Or put it in the chat here if others want to see it as well.
Yeah, I think you know, if you're lazy like me, you know, and you don't want to look up the specifications of a part or say, you know, okay, I can run this at 3.3 volts or 5 volts. You know, what do I lose if I run it at 3.3? You know, just a generic question like that, and you know, pretty high level, and it'll come back and say, you know, I looked through all the specifications, can't really see anything that you lose, you know, in that, you know, switching to the lower voltage and things like that, or, you know, so it's, you know, it just saves me a lot of time, you know, having it kind of research those things, you know, for me, so I don't have to do it. So, or even if, you know, it's like I forget the pin out of something, as, you know, okay, what's the pin out of blah, 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 and it'll pop up a picture, you know, it's like, oh, all right. Or at least a link to a picture, you know.
So yeah, so Claude AI. Copy. I'll throw it in there.
Yeah, it'll be interesting to know if with a free account with Claude AI, because I think they might have a Visual Studio Code plugin as well. Although
Okay.
they're focused on the command line thing called Claude Code. I don't know if you can use that with the free account. If you can, then that would certainly be a good option.
So I've got a number of different projects or chats or whatever I've worked on here before, and I'm just trying to find the last one because I don't remember the last one. Not STM.
I'm gonna ask the AI if a free account can be used in Visual Studio Code.
MicroPython.
Because again, you want to be living in Visual Studio Code, not in the browser in some chat interface. It's just not productive.
Yeah, that's where I'm in the chat interface. So
Yeah.
it does it, and it's a pain because you got to pull out all the files and everything. But I'm trying to find one. I thought I had one in C++, and I can't find it. Everything I have in here is in Pi. Oh, there's one.
Oh, the Arduino AI assistant is using Claude.
Oops.
But which one, right? Which generation?
I can't tell.
Yeah, okay. So according to Google AI Mode, with a free Claude.ai account, you can't use that account inside Visual Studio Code.
Yeah, so that's right.
You gotta have a paid account. So you get the web interface, you get access to Solid 4.5, which is pretty good, but you don't get that now in Visual Studio Code. You gotta upgrade the account.
Yeah.
So one way or the other, like I said, you gotta pay money. The free stuff you get is GPT 4.1. We saw that earlier, right? And yeah, it's just not gonna it's just not gonna be satisfying if you limit yourself to those free things.
So GitHub Copilot for individuals has a 10 US plan. I don't know how.
Yeah,
Per month.
this might be. I don't know what exactly, to be honest, but I am paying GitHub some money, so I forgot the exact number, but it's certainly not more than 20. That's all I pay for all these guys. I have a like $20 account with most of these companies except for Claude. But GitHub, it's either 20 or 15, or maybe it's just $10, in fact, that I'm paying them.
Yeah, it depends if you're business or individual. There's an individual plan, and it's $10 US per month, $100 per year. So in Canada, so that's $14 Canadian a month, 40, $14.50 or whatever it is Canadian a month, and whatever. But there's a 3-month trial or 30-day trial. Sorry,
Give it a shot.
that you could give it a try and see how it would work in VS Code. So that's before I would give it a shot. That's I'd like to say, okay, well, how do we get this up and running and give it a try? So.
Can you sign up with different, Gmail accounts or something? Just have 10 of them that you cycle through.
Yes, one of the folks in the Vancouver robotics group that I attend basically runs half a dozen different AI tools. And when he runs into the time limit on one, he simply copies and pastes his code into the next one.
There you go.
Yeah, okay. I looked up the pricing. Yeah, the $10 account. I'm guessing that's what I have because it says you get 300 premium requests per month.
Yeah.
Yeah, that's so good because you have this thing. It says, okay, 100% of your budget is still left. Every time you make a prompt, it's using up 0.3%. So that amounts to the 300. And then depending on what model you're using, it amounts to 300 per month. Smaller models like Haiku, they cost you less, so you actually get 3 times as many. Every request only costs you 0.1% of an allowance, right? And then the other end of the spectrum is things like Opus 4.5, which is the top of the line that everyone is raving about. They have 3 times as much, so you actually get only 100 Opus 4.5 requests per month, right? With that $10 account, $10 a month account. I would say it's worth it, and because what's nice about it, you're not stuck with one provider. You get access to the clouds, and you get access to the codexes, and so you can play with different ones, and they have the strengths and weaknesses. So honestly, that $10 a month, I thought I was paying more. I better look into that. Is really a good deal for what you guys are trying to do in the IDE. And
Kind of
Yeah.
sounds like, Chris, though, you're working on stuff that's a whole lot more complex than I'm doing. I mean,
well, yes, again, and right now, I mean, at home currently not as much as at work, yes, but still, it's just, even if it's not complex, right? Like I said, at the minimum, you want to be doing this in the IDE and not in the chat interface.
Yep.
Even if you just limit yourself to the things that you get free in Visual Studio Code, do at least that.
Yeah, well, that's what I'm looking at is that, what are they saying about programmers and AI systems like this? That a programmer that isn't using AI is going to be a programmer that's, going to be laid off eventually. The world is changing, and everybody is using AI, and it's something that, I've been putting off, but it's something I need to learn to use as a tool.
Yeah, and it's still, again, the way to think of it is it's not about, oh, but it made this mistake. Oh, it can't do that. Right? That's today. Fast forward 2 years. Think about what it's going to be like 2 years from now. Right?
Exactly. If, at $100 US a year, if for $200, you can triple your code efficiency, productivity, whatever else, what's the payback on that job-wise? It's big. Hobby-wise, well, not so big, but, if you can advance your hobby as well, it may be worthwhile if that's what you're into. If you want to, if we want to compete at Roborama and, we're having issues with our code and we're stuck, it may be able to help us out and figure things out.
Yeah.
There's a lot of people out there that have done stuff before that, and that's where that's where these systems get all their knowledge. They're out there scraping the net and finding out what people are doing,
and sometimes we want to do it the hard way, right? That's part of the fun is, right? You it's kind of a learning, and you're solving the problem yourself. But sometimes you just don't want to get stuck with a particular stupid problem, right? Because you want to get to the next thing. So So, and that's why it's still for us applicable, right? I mean, but obviously for us, the fun is in actually doing some of the things the hard way, right?
The hard one. There's enough hard things to do that, it'd be nicer to just get rolling and get things moving ahead.
Right.
And that's part of it. So you've answered one question at least, that, the GitHub AI plan, or whatever, the Copilot plan, may be a way to go. And for $10 US a month, it may be something worth trying. I don't know if I'd be committed to the $100 a year though. So.
Well, if you're doing $10 a month, you're at 120 a year. So
I know, but if I'm doing $10 a month and I find that in 2 months or 3 months I can't, I don't have to keep up with it. You pull the pin on it.
yeah,
Exactly.
So
Yep.
it's I use Rust Desk. So when I travel, I don't bring my 2 laptops now. I use Rust Desk to connect to home. And I was testing it out. I was using I have a VPS that I pay for to a server, virtual server, and it manages my Rust Desk, basically my connections. It's nice, and I can securely log into home, and I can check things and check the cameras and whatever. Find out if my wife is doing the driveway okay in the winter. All sorts of things like that.
she's out on the snow. Yeah.
I was paying 11 something US a month, or 11 something Canadian a month, $8 US. And I said, well, that's awfully expensive for what I use. I use it 6 times a month. And looking around, and I found one for $2.15 a month Canadian. And so I switched it over, and that's what I'm running. So you try to find something that works, that's affordable. Everybody wants that $10 out of your pocket every month. And, it adds up. And so finding if you can use it, if it's worthwhile, yes, it makes sense. If you don't, that's why I like to be able to say, okay, it's not working for me, I'm going to turn it off.
Yep. Just like Netflix, you got to watch a few movies every month.
Oh, we can get back on a robotic topic. Rain would like to share a status on the robot.
Go for it.
Can you hear me?
Yeah.
Yes, we
Okay.
can.
I think because I don't have a camera on this laptop, I'm going to have to switch to my phone real quick. Give me just a second.
Thanks for interjecting, Kareem.
Sure.
I think we talked about the AI topic.
It's so easy to get derailed by AI these days, isn't it?
Yes.
Beat that topic to death, huh?
Where'd my Discord go?
Yeah, Mike, the problem that you were having the other day where your head is in the center of your laptop, or maybe pointing at your camera, but in the image it's shifted over. Or mine's doing that tonight. So how did you what was the fix for that?
Hover on your picture, there's a little weird icon you click on to recenter your camera.
Oh, okay. Oh, there we go. It worked. Look at that.
Not for me. You're still on the right. I got the left.
I'm centered on my image.
Tom's muted, but he used the chair.
Oh, Ray is centered on my screen.
There we go.
Huh, that's weird.
I never noticed that before. Isn't that interesting?
I'm taking up too much real estate here. I'm going to shrink it back. I'll sit off to the side here.
It's when you're eating your supper and you don't want people to watch you eat. You can move over to the side.
There's Kareem.
Oh, Wrong camera. Say hi, guys. Turn on microphone. Try it again.
Hello.
Hello.
Oops.
Are we doing it now?
You are presenting. You need to talk out. Or
Right.
you can take my.
So we've been
So
working.
you're gonna have to drive.
Well, we're gonna show our autonomous first. Right now, we've been struggling with consistency and timing out because of the third and second period. But we figured out the navigation pretty consistently now. But I'll show you what it's doing. In a minute.
Is that the little R2D2 shake there? Yeah. Gives a little.
And that was it timing out. We've been able to clear the first row of balls and the first and second shoot times. It usually scores 2 out of 3, and then depending on if the pit is being too strict, it can sometimes make it to the second row of balls and intake them to get ready for teleop. And we can show you the teleop right now. This is our human driver controlled. Oh, that might be the vision from the autonomous being weird. So you might have to aim it. Shoot these and then release the gate. Yeah, so that's probably good.
So is that a
That's-
bonus if they pop over the tube in the gate? You get a
We aren't really supposed to do that. We're supposed to empty it before firing,
Oh.
but we're kind of just showing the demo of the shooting and intake in teleop.
You actually lose points.
Yeah, they don't count if they roll over. Is there any questions?
Was any of this autonomous or all teleop?
The first part you saw, where it started
That's
near
not
the goal,
Oh.
shot and intook this first line of balls, that was autonomous.
Okay.
And then
Okay.
the section driving here and then taking, that was all human.
So when you're shooting them into the goal, you have to be a certain distance away. You can't adjust the angle. You have to just adjust the distance.
For us, we only
Yeah.
have one shooting spot since we have a set speed for our flywheel.
Okay.
But you can shoot anywhere within the triangle, which I think is what we're going to try and work on.
You have future plans to
Oh yeah, we can shoot. We can shoot from anywhere on the field, like it is capable, but it's coded right now to only shoot from that one reliable point. But
Right.
we have plans to be able to shoot anywhere on the field by making a linear regression of the distance and the speed needed to accurately score.
and that'll give us an equation that we can just plug a distance into, and it'll give us the correct speed we need our flywheel to be at to correctly score from any distance.
Okay, so for the demo, you just have a fixed speed, so you have to be in a fixed area. So
Yes.
okay, great.
That's excellent, guys.
Thank you.
Thank you.
I in my notes, I gave you guys a gold star for the autonomous mode.
I think that's the first time I've heard that.
For what it's worth, anyway, a gold star for the DPRG.
Thank you so much.
All right, they're gonna get back to it.
Yes. Thank
How
you.
much longer do you have to work on this before the competition?
We got until Saturday.
Oh, wow. Okay, get to work, guys.
Get to work. All
No
right.
sleeping.
Thank you.
Thank you.
That's excellent. They're making a lot of progress.
Wonder how many hours a week they spend on that.
Yeah, they're spending plenty of hours a week on it right now.
And Kareem, am I right that this is all after school stuff?
Yep, after school and weekends.
Wow.
And we got hit
Dedicated-
hard by the storm. We in the 2 weeks leading up to competition, we lost a full Saturday. Our regular practices are Saturdays. We lost a full Saturday and then pretty much the full week after that. So, yeah, things are in a crunch right now.
So you're saying they didn't cross country ski over to your house or,
Yeah, no, we're a little far away. Most of them are in North Dallas, I'd say, and or East Dallas, but yeah. No, I was locked in. We got this long driveway, and we still got some ice on it. So, the last of it is disappearing today.
I really feel for you, Kareem.
got all that ice, it's, half
I
inch-
shoveled I snowblowed 5 inches out of my yard today, driveway and yard. So
Yeah. Yeah, we're completely immobilized with just a little bit of frozen water.
yeah. Well, you don't have the systems in place to get rid of it like we do.
No, we don't.
Okay, I've got something to present. Ed is the one that gave me this, and it's just a quick video. If I can remember how to share, it's been so long. Share. Entire screen, this guy, share. All right, can you guys see a picture of a robot?
Yeah, looks like it's got a handgun on the top of it.
Okay, so you can see it. I don't think there's any sound, but I thought that this got shared to me by Ed on the weekend, and that's not too great of an idea. I think it's just an airsoft gun or something. I'm not sure. Just a robot running around.
It's a patrol agent. Does it shoot stuff?
Yeah, so there was a couple of you guys working on Sentry robots, right? Well, there's an idea for your robot.
I'm
So a
going
new
with the
contact.
taser.
Yeah, I'd like to find out what well, they're not glitter bombs anymore, they're porch pirate bombs. What they're actually using to throw that much paint. It seems like a pretty good explosion. So
Yeah, definitely interesting concept anyway. I think it was just a remote control thing, but
oh, the porch pirate bombs?
no, the robot. The porch pirate bombs, that's yeah. Careful what you open.
Yep. Yeah, some of them, they actually use, expanding foam, and it hardens in the car. So it pretty much, you'd have to chisel it all out to.
That stuff is like glue. It's
God, yeah, yeah, it's nasty.
horrible.
Yeah. So.
Okay, guys, do we have any more?
Good night.
Okay, guys, I guess we're going to call it.
All right.
Sure.
Right.
Good night.
Here's all.
Good night.